Okay, here's a question about a curve with that equation, which they very kindly sketch for us. First thing we've got to do is state the coordinates of the point B, which is where the graph cuts the y-axis. There it is. For the y-intercept, the x-coordinate is 0, so we just substitute the right value in for x into the equation and get the y-coordinate. And then, hence, using that, we've got to find the area of the triangle AOB. Here it is. And we've just found the y-coordinate of B, so we know the height of the triangle, and we can look at the coordinates of A and get the base of the triangle. And from GCSE you should know that the area of a triangle is a half times the base times the height, so that should be all you need in order to get these 3 marks. A.E2, re-entry point, we don't need to A.E1 for this at all, we just need to integrate 3 terms to 3 marks. So use the rule from chapter 7 for integrating powers of x. There should be a little bit at the end which you mustn't forget, but essentially integrating the 3 terms is what gives you the 3 marks. Then we've got a hence question. We've got to hence find the area of the shaded region, which before I decorated the diagram was just this bit here. Now hence means you've got to use what you've just done. We've done an integral, but in order to turn that into an area we need to put suitable limits on. So you can take your answer to part 2, put it in square brackets, doesn't need the plus c on it at this stage, put the appropriate limits on, substitute them in and subtract as you normally do, and get an answer. But that answer won't be for just this little strip of area, that answer will be for the entire area, but you should see a way of combining that answer with your answer for the area of the triangle AOB to get the area you're after. And there are examples of exactly that style of calculation towards the end of chapter 7. That was part A. Part B is a big fat re-entry point. You don't need to have done anything from part A to have get full marks on part B. If you look at B1, we've got to find the gradient of the curve. The gradient of the curve here is the same one, but they restate the equation for you. Gradients are dy by dx. So we need to get dy by dx for this particular equation. But we don't want the gradient any old place, we want the gradient at the point A. So at this specific point we've got a value to substitute into our dy by dx. That will give out a numerical gradient and that will get you 3 marks. Hence, in other words, using what we've just done, we've got to find an equation of a tangent to the curve at the point A. A tangent is a straight line, so we're going to be using our recipe from chapter 3 for a straight line, the one that begins y minus y1 equals. And to use that recipe you need 2 things. You need a point and you need a gradient. So the point, well the tangent goes through the point A, and we know the coordinates of the point A, so that's alright. And for the gradient, we need the gradient of the tangent. We've got the gradient of the curve from B dot E1 at the point A, so it'll either be that gradient or it'll need adapting. Okay, so make your own decision on that. But set up a point, set up a gradient, the point's given, the gradient will come from B dot E1 in some shape or form. So set up your equation of the tangent.